All right, we're going to do some quick review from chapter 1 and 2, and then we're going to do some of the problems that are on Moodle. All right. So, chapter 1, just a quick review of what could be on the test. Make sure you know your scientific method. All right, there could be a multiple choice question. It could just be explain the scientific method. Normally, it's a multiple choice question, if there is one at all. Law of conservation of mass of reactants equal mass of products. There will be a problem on that. And all problems on every test, sig figs are graded. Make sure that you're getting the correct answer and giving it to the correct number of sig figs. You have to know your characteristics, solid, liquid, and gas. Make sure you're familiar with that. You have to know the difference between a physical change and a chemical change. There will be questions on melting, and you have to label that as a physical change. Rusting, you have to label that as a chemical change. Make sure you know the difference between a physical change and a chemical change. All right, and then related to that is your physical properties, like your boiling point, melting point, solid, liquid, gas, and your chemical properties. If it says anything about a reaction, it is a chemical property. It reacts with oxygen, it reacts with fluorine. Anytime you hear the word reacts, that is a chemical property, because a chemical property is a reaction that it does a chemical change in. All right, substance. All right, you have your flow chart here. So be familiar with this flow chart. Matter is at the top. You have substances and mixtures. So a substance is your elements and compounds. So when you're writing reactions, you write reactions with substances, they're elements and compounds, and then they form other elements and or compounds. And you know your mixtures. You have to know the difference between a homogeneous mixture, where it's a solution, the same throughout, versus a heterogeneous mixture where you can see two distinct things. If you have your copper and water, that is a mixture of copper and water. You can obviously see the two different things. You can see the water, you can see the copper. Whereas salt water, if you have a salt water solution, you cannot see the salt in there. That would be homogeneous if you cannot see it if it's the same throughout. All right, measurements. So the big part of chapter 1's problems is going to be converting from one unit to another unit using your conversions and giving your answers to the correct number of sig figs. That is going to be a big part of chapter 1. Usually there's a question, multiple choice question, about the difference between precision and accuracy. Precision is if you're very precise, you can hit the same spot every time. All right. You're very accurate if you hit the bullseye every time. So if you are not precise, that means you're all over the chart. And if you are not accurate, that means you do not have the correct answer. So if you did your lab and you had 3 different answers for density, well, that would be bad precision. But if you average it out and you got the right answer, that would be a good accuracy. All right, so again, good precision, poor accuracy. This has poor precision all over the place, but the average here is the center. So when you're doing a lab, that would be the right answer when you took the average of all those. And of course, here is good precision and good accuracy. All right, so again, sig figs. Sig figs are the most important because it is this test and every other test, this lab and every other lab. And so sig figs are worth a lot of points because it is always used for everything in chemistry. There are two rules. Remember, when you're adding and subtracting, you have to go by decimal places. And it is always, you give the answer as there are in the measurement with the least number of decimal places. So if you're adding up two numbers, one has one decimal place, one has two, your answer would have one decimal place. You have to know an exact number. If you can count it, if you see, okay, I have three of them. Yes, obviously I have three of them. That is an exact number. Any conversion factor, 1 inch is 2.54 centimeters. Any conversion factor is an exact number, will not determine the number of sig figs that you give in the question. Make sure you know the rounding rules. If it is 5 or greater, you go up. If it is less than 5, then you leave it alone. Know how to round your numbers. All right, so if you want to go to 3 sig figs, so the 1 is certain, the 2 is certain, and so going to 3 sig figs, that last digit has some uncertainty. All right, and so you want to round this to 3 sig figs. So you have your 1 here. All right, so you have the 5 after it, and so that is greater than 5, 5 or greater. All right, so you go up 1, so 1.22. If this was a 4.3 instead of a 5.1, now it is less than 5, and so you don't do anything. You just get rid of those numbers. You do not go up. All right, your choice for rounding is you increase it by 1 or you do not change it. If it is higher than 5, you go up by 1. If it is less than 5, you do not change it. All right, so there will be many questions like this. Very simple. You have your calculator. It's easy to get the answer. The question isn't, can you push the buttons on your calculator? The question is, can you give it to the right number of significant figures? All right, so here you have 5 sig figs, here you have 4 sig figs, and here you have 3 sig figs. And that is the lowest number of sig figs. You are doing a multiplication in the denominator. You're doing a division. All right, so it's all about sig figs. So when you are multiplying and dividing, it is about sig figs. Adding and subtracting, decimal places. So when you push the buttons on your calculator, you get this giant number. All right, and now you have to be able to give it to 3 sig figs. And so we have a certain number, and a final number having some uncertainty. And that is a significant digit. And since that is less than 5, you do not change it. You just get rid of those things and leave it as 0.734. All right, so here, again, you have to, it's a very simple question. Anybody can subtract these two numbers, especially when you're given a calculator. All right, and so you have 3 decimal places and 2 decimal places. Again, you have to always think, am I adding and subtracting or am I multiplying and dividing? And know the 2 rules. So when you're subtracting, it's decimal places. So when you get your calculator answer, all right, your calculator isn't going to put a bunch of zeros on there unless you have a different kind of calculator. This is what your calculator will say. All right, and so you have to know that you're going to 2 decimal places. All right, and so here, again, this would be a bad example because if you use the wrong rule and said 3 sig figs and 3 sig figs and gave it to 3 sig figs, that would be the right answer. The ones on the test, if you're using the wrong rule, you get the wrong answer. So make sure you're using the correct rule. All right, so since the 7 is greater than 5 or greater, so you go up to a 4, negative 1.14. All right, so here's one that would be on the test, because on the test, you would have 3 sig figs and 3 sig figs, and if you gave your answer to 3 sig figs, you'd have the wrong answer. So you have 3 decimals minus 3 decimals, you give your answer to 3 decimals. All right, so again, I may not like this one for the test either, because this is what your calculator says, and that is the correct answer. Most of the time, you have to round correctly and not, if you give what the calculator says, most of the time that's the wrong answer. In this case, it's the right answer. 3 decimals minus 3 decimals gives you 3 decimals. You have 3 sig figs, 3 sig figs. Your final answer only has 2 sig figs. You don't follow the sig fig rule. because this is not multiplying and dividing. You follow the decimal place rule. All right, many of your calculations will have more than just adding or subtracting and multiplying and dividing. They'll have them combined, both of them, both rules required to be used in the same question. All right, so you do your parentheses first. You got your 0.035. This is what you do first. So you had 3 decimals, you gave your answer to 3 decimals. But now you're multiplying that by 92.35. So now when you're multiplying, you got 4 sig figs, you got 2 sig figs, and you give your answer to 2 sig figs. Make sure you are following the sig fig rules. And so here's what your calculator says, but you can only give that to 2 sig figs. Since that number is less than 5, you simply get rid of those, and your answer is 3.2. SI units, make sure you know your SI units. You need to know the SI units. All right, so table 1.1, get rid of the last two. There will be no questions on these two. There will be questions on the others. So you have to know length is meter. The one that is missed most common is the SI unit for mass. It is the kilogram. It is not the gram. It is the kilogram. Time is seconds, temperature Kelvin, amount of substance mole. Make sure you know that. That should be a very simple multiple choice question, or it could just be convert this, whatever units I give you, into the SI units. If you don't know what the SI units are, you cannot get that question right. All right, and here is your chart, table 1.2. These are the ones that you need to know. So I can say convert this to picometers, nanoseconds, whatever. You have to know all of these conversion factors. So make sure you have these memorized. All right. So again, anytime you're in lab and you have a scale, you're going to give all certain numbers. And so what you're certain about in this is that it's between a 5 and a 6. And so we know it is 5 point something. We have to estimate that point something. We know it's greater than the 0.5. It looks like a 5.7, say. All right, so I would say here is a 5.7. And so this can only be given to 2 significant figures, 5.7 centimeters. All right, so you always give all certain numbers plus one final number having some uncertainty. And determining if your zeros are significant or not. All right, so remember, if you're not 0, you're significant. If you have a bunch of numbers and they're not 0, they're always significant. If you have zeros between numbers, so example here, if you had 123.25, you got 5 sig figs. All right, so if it's not 0, it's significant. If it is 0, let's say we had 103.25, you still have 5 sig figs. All right, so any zeros that are between non-zero digits are always significant. Leading zeros like 0.00125, these are not significant. And so this is 3 significant figures. And we would convert that into scientific notation to be even more clear. And that would be a 1.25 times 10 to the minus 3. All right, so you move your decimal to the right 1, 2, 3 places. All right, and so that is very clear that that is 3 significant figures. All right, so you don't write numbers like 0.001.25, so you don't put the zeros in front. Terminal zeros are significant if they are to the right of a decimal point. So if you had 0.012000, all right, leading zeros, not significant. You have a decimal point. The following zeros on the right of the first non-zero digit, those are all significant. And so this would be 5 significant figures. All right, and so remember the rule for number 5. If it is less than or equal to 1,000, then the zeros are significant. I didn't write the right. Okay, so let's go to a different page. All right, so if we had numbers, let's say we had 3,750,000 years old, and we had 100 milliliters of water. All right, so here is the rule. The rule is if you are greater than 1,000, then the zeros to the right are not significant. So if you are greater than 1,000, then zeros to the right are not significant. All right, and so the answer here is 3 sig figs. Here, if your number is less than or equal to, if you are less than or equal to 1,000, then the zeros are significant. And so this is also 3 significant figures. 100 is less than or equal to 1,000, and so the zeros are significant. All right, and so we would put these in scientific notation to be very clear and have 3.75 times 10 to the 6th years old. All right, so this time we're moving our decimal place to the left. 1, 2, 3, 4, 5, 6 spots. That's where the times 10 to the 6 comes in. And this one would be written as 1.00 times 10 to the 2nd milliliters of water. All right, so again, we are moving the decimal 1, 2 spots to the left. All right, so large numbers, numbers greater than 1, have positive exponents. Small numbers, numbers less than 1, have negative exponents. Whenever you're converting to scientific notation, do not change the number of sig figs. If you had 3 sig figs, you convert it, you have 3 sig figs. You have 3 sig figs, you convert it, you have 3 sig figs. Never change the number of sig figs when converting into and out of scientific notation. All right, so again, here's a number less than 1, and so it is 6.53. And then you have to see how many places you move your decimal. That's 1, 2, 3, 4 times 10 to the negative 4. It is negative because you're going right. It's also negative because it's a small number. All right, here you got 3.5 times 10. Oh, okay. Interesting question here. I just went right to the answer. 1, 2, 3, 4, and 5 times 10 to the 5th. Note, here we have 3 sig figs because leading zeros do not count. 3 sig figs. Here, this number is greater than 1,000. It is 350,000. Zeros are not significant. This is 2 sig figs. This is 2 sig figs. Here, leading zeros, not significant. Trailing zeros are significant. So you have to have 4 sig figs here. When you convert it, it must have 4 sig figs. 2.700 times 10 to the minus 2. Again, when you go from non-scientific notation to scientific notation or the reverse, never change the number of sig figs. All right, write the following measurements without scientific notation using the appropriate SI prefix. All right, so again, if you have the chart memorized, you know that 10 to the minus 9 is equal to n. And so this is simply 4.851 ns, nanoseconds. If you have 10 to the minus 2 memorized, 10 to the minus 2, that is equal to c. And so you have 3.16 cm. If you have 10 to the minus 12 memorized from that table, that is p, pico. And so you have 8 0.93 PS, picoseconds. So this is just did you memorize this chart and know what 10 to the 9th, 10 to the minus 9, 10 to the minus 2, and 10 to the minus 12 are? So again, that was the chart right there. All right, so all you had to know is this chart. If you know 10 to the minus 2 is C, you simply get rid of that and put C. The same thing. 10 to the minus 9, that's equal to N. This is an equals, equals, equals. They are the same thing. And when you do a conversion factor, P divided by 10 to the minus 12, that's 1 because P is equal to 10 to the minus 12. All right, so here we have to do conversions. All right, so there'll be a lot of these on the test. Make sure you can do them. These are the easiest ones that you will see on the test. Most of them will be a little harder. So let's make it a little harder and do the last one. Instead of grams, it'll be to the SI unit. All right, that's about as hard as it's going to get because now you have micrograms and you have to go to the SI unit. You have to know that the SI unit for mass is kilogram. All right, so now you have 5.23 micrograms. And so when you show your work, you know that a microgram is equal to 1 times 10 to the minus 6 grams. Back to that chart. We had nano was minus 6. We have pico that's minus 12. We have centi that's minus 2. Micro is minus 6. You have to have that memorized. But that's not our final answer. The answer was not go to grams. The answer was to go to the SI unit, which is not grams. It is kilograms. So we have to get rid of grams and we have to give kilograms. Again, you have to go to the chart and say that K is 10 to the third. And so I always write it. You can multiply anything you want by 1. I always put a 1 times 10 to the third. And so now when you push the buttons on your calculator, you get 5.23 times 10 to the minus 9 kilograms. All right, so these are all one-step things. This would be a two-step thing. Most of those are going to be more than one step when you do a conversion. Temperatures, you only have to know Celsius to Kelvin. All right, so if you are given a Celsius, okay, anyway, your temperature in Kelvin, that's equals to your temperature degrees Celsius plus 273.15. All right, so that's the equation that you need to know. When you're given a Celsius, you plug it in here. If it's minus 34, plug in minus 34, you get 239. Now note, this is an addition question. And so if your number was minus 34 Celsius, that's 0 decimals. This is 2 decimals. You give your answer to 0 decimals. All right. So that is 3 sig figs. That's not the way you should state it. I add 0 decimals plus 2 decimals, and I give my answer to 0 decimals. All right. So area is a length times width, so it's 2 units of length, and so it's meters squared. Volume, length times width times height. And again, 3 distances that you're measuring, all of them in the SI unit of meters. So you have meters times meters times meters, meters cubed. Density, the SI unit for density. You have to know density is mass over volume. There will be a lot of density questions on the test. All right. So not only do you have to know its mass over volume, you have to know the SI unit for mass, kilograms. You have to know the SI unit for volume, meters cubed. All right, so when we did our density in lab, we have grams per milliliter. In chemistry, we don't normally use the SI unit. All right, so a good question would be then to convert that to the SI unit. Speed, distance per time, so that's meters per second, and acceleration is meters per second squared. So you should for sure know your density, which means you will actually then have to know the volume. And so let's go ahead and do the area and speed and acceleration. So you should know all of these SI units. For this test, I'm not going to have your force, your pressure, and energy, but we will in following exams have your force in newtons, which is a kilogram meter per second squared, pressure in pascals, that is a kilogram per meter times second squared, and energies in joules, kilogram meter squared per second squared. That's not going to be a question on this test, but next test it will. All right, so again, density, lots of density questions, mass over volume for solids and liquids, which we did in lab. We have it in grams per centimeter cubed or grams per milliliter, and that is the same thing. A centimeter cubed is equal to a milliliter. You need to know that. You must know a centimeter cubed is exactly the same as a milliliter. All right, and when we do gases in chapter 6, we will get units for the density of gases is grams per liter. None of those are the SI unit. The SI unit is kilogram per meter cubed. All right, so we will have questions just like this, which are similar to the lab. All right, so you have oil of wintergreen. It is a liquid. We are getting the density of a liquid. We took 28.1 grams of oil of wintergreen and we put it in a graduated cylinder, and it had a volume of 23.7 milliliters. And so as long as you know to take the mass, 28.1 grams, and divide by the volume, 23.7 milliliters, and you have 3 sig figs divided by 3 sig figs, and you give your answer to 3 sig figs. This is a very simple question, right? So you have 1.19 because that is a 5 or greater, and so it goes up by 1. Make sure you have the right sig figs. Make sure you have grams per milliliter. You can't say that the density of this is 1.19 because we just saw in the last slide, density has all kinds of units you can use. Grams per milliliter, grams per liter, kilograms per meter cubed. You must put the units. All right, so sometimes you're given the density and you're given a volume, so it doesn't have to be solve for density every time. Density is equal to mass over volume. You have 3 things. All you need is 2 of them. You can solve for the other one. So if you're given the density and you're given the mass, you can solve for the volume. All right, so you can solve for volume by multiplying both sides by volume. That gets rid of the volume here. Divide both sides by density. That gets rid of the density here, and you will end up with mass divided by density. That is your volume. So you simply put in your mass, you put in your density, and then you divide those 2 numbers. Again, 3 sig figs, 3 sig figs. You give your answer to 3 sig figs. Since that was less than 5, we did not change it. And you must put the units, 632 milliliters. All right, so here is one where, very similar to one we already did, we have 573 milligrams. And we want to go to kilograms. So again, you get rid of the milligrams. Again, you have your chart. You know that M is 10 to the minus 3. I always write 1 times 10 to the minus 3. I like that better than just 10 to the minus 3. All right, but I don't want grams. Well, I do if you answer the first question. I'm going right to the one question where it's go to kilograms. All right, and so I want kilograms, which means I have to get rid of grams. K is 10 to the third. 1 times 10 to the third. And so when you push the buttons, you get 5.73 times 10 to the negative 4 kilograms. Make sure you're putting this in your calculator correctly. Milligrams are going to cancel. Grams are going to cancel. All right, so make sure you're plugging these in right. If you're not always getting the right answer, you're not using your EE button. You're using some other button that is not going to work when you are dividing. Make sure you always get this. Know how to use your calculator. Do not miss the problem because you don't know how to use your calculator. All right, so kilograms is the 5.73 times 10 to the minus 4. All right, so here is another one that will be on the test as well. Make sure that you can go from 54.3 milliliters into cubic meters. What we do know is that a milliliter is exactly the same as a centimeter cubed. And so we can go right to 54.3 centimeters cubed. All right, so now that we have 54.3 centimeters cubed, now we have to do the conversion of centimeters to meters 3 times. All right, and so we get on the C, we know from our chart, that's 10 to the minus 2. And again, I always put 1 times 10 to the minus 2. 1 times 10 to the minus 2. All right, so centimeters times centimeters times centimeters cancels centimeters to the third. And we have meters times meters times meters, which is cubic meters. And so you get 5.43 times 10 to the minus 5 meters cubed. All right, so make sure again when it's when your numbers are all in the numerator, if you use your calculator wrong, you will get the right answer. As soon as you have to divide by something, if you're not using your calculator right, you will get the wrong answer. All right, sometimes you're going to be given units that you don't know, like carats. You don't have anything memorized for carats. And so then in the problem, there's going to be a conversion factor given. And in this case, 1 carat is equal to 200 milligrams. All right, so here I would not put 3 significant figures. Since this number is less than or equal to 1,000, the 0 counts. That's 3 sig figs. And this is a conversion factor. 1 carat equals 200 milligrams. All conversion factors are exact. I don't have to tell you that it is exact. All right, so you have 330 carats, and you have a carat is 200 milligrams. And so the question asks, what is the weight in grams? So this is what it would be in milligrams, but we don't want milligrams because it asks for it in grams. 10 to the minus 3 is milligrams. All right, so then that is 0.2 times 33, that's 66.0 grams. So here you have 3 sig figs. Here you have infinity. Here you have infinity. The smaller number between 3 infinity is 3. And so when you get your answer, it must be to 3 significant figures, which is a 66.0 grams, or you could put it in scientific notation, 6.60 times 10 to the first gram. That is also fine. Okay, so again, lots of conversion factors. Easiest questions on the test are these. Do not miss these questions. This is simply, do you know your rules for your zeros? All right, so that's 4 sig figs. This one is all of the zeros to the right of the first non-zero digit. When you have a decimal, leading zero is not significant. So 6, not significant. Yes, significant. 4. Decimal place, yes, significant. 4. Decimal place, yes, significant. 4. Greater than or equal to 1,000. 91,000 is greater than 1,000. And so this is only 2 sig figs. So the only one that should be of any difficulty is the last one. All right, so that was a quick review of chapter 1, quick review of chapter 2. I don't know how quick this review is, but okay. All right, so go through the postulates of Dalton's atomic theory. You don't have to memorize them, but you should be aware of them. There could be a multiple choice question about which one of these is or which one of these is not one of Dalton's postulates. Know what it means by law of multiple proportions. That means that carbon and oxygen can combine in as a CO, carbon monoxide, or in a 1:2, which is CO2. All right, so easy questions would be structure of the atom. Make sure you know that the nucleus is the center. It has the protons and neutrons, which means it has all of the mass. Electrons aren't zero, so most of the mass. When you add in the electrons, it doesn't change the actual integer value for the mass. So you have to know that. You have to know that the electrons are outside the nucleus, and they are very light. The mass is not zero, but it's very small. And electrons are negative, protons are positive. I don't ask for who discovered the electron. All right, so I do ask a lot of questions about nuclide symbols. So make sure you know what it means to write a nuclide symbol, because that might be as simple as it is. Write the nuclide symbol for carbon-13. If you don't know what it means to be a nuclide symbol, you can't answer the question. All right, it simply means you write the mass number, which is A, on the upper left, and you write the atomic number, which is number of protons, on the lower left. And so it's a very simple question. Write the nuclide symbol of carbon-13 because I circled it here. But if you don't know what the question's asking, you can't give an answer. So make sure you know what a nuclide symbol is. And it will say how many protons, neutrons, electrons. Right? So again, you have to know that Z is the atomic number, which is the number of protons. So your atomic number equals number of protons. That is always true. That is never an exception. All right, so if you are carbon, you have 6 protons. If you have 6 protons, you are carbon. That's it. If you have a different number of protons, you are not carbon. All right, so 6 protons is carbon. I gave no charge, and so since I know that the protons have a plus charge, I have to have 6 electrons that have a negative charge because my charge is 0. All right, and then the harder one is the number of neutrons. So you have to know that the number on top, the A number, is equal to the protons plus the neutrons. So you have to know your mass number. The mass comes from the protons and the neutrons. Electrons' mass is so small, it does not change that value. So when you have 13 as a number of protons and neutrons, and 6 of them are protons, well, you have 7 neutrons. All right, so these should be very simple questions. You should not miss how many protons, neutrons, electrons. So lithium, 3 protons, 3 electrons. And since the mass number is 7 and I have 3 protons, I have 4 neutrons. Sodium 23, 11 protons. Since it's neutral, that's also 11 electrons. And since the mass is 23, I need 12 neutrons to add up to 23. So these should be very simple questions. All right. So I'm going to ask a different question here. I'm going to say the answer to this one is potassium, because potassium has 19 protons, and when we're talking about potassium 39, it has 20 neutrons. All right, now I'm going to put it as a plus charge. So my question now is, I want the protons, neutrons, and electrons for potassium 39, but it has a plus charge. All right, so the key here is this number right here. This number is always the atomic number. It is always the number of protons. If you change the number of protons, you do not have potassium. If you have K here, this must be 19. If this is a 19, it must be 19 protons. If you change the number of protons, you have changed the element. All right, so it is potassium. It is written as potassium. It is 19. That is protons 19. That never changes. I didn't change the mass number, so we still have our 20 neutrons. This is 39. When you have a charge, you can change the number of electrons. You cannot change the number of protons. If you change the protons, you change the element. All right, and so since we have one more plus charge than we have minus charge, we have 18 electrons. So we have 19 protons, 20 neutrons. So we have 19 plus charges. We have 18 minus charges. That means we have an extra plus charge, and that's why it has a positive charge. All right. So again, make sure that this is always the number of protons. Always the number of protons. All right, there is always a question about finding the molar mass by using percent abundance or fractional abundance and your masses. All right, so you again have to multiply these together, but before you multiply them together, you have to convert this to a fraction. All right, all those have to get converted to a fraction. Note, I can leave one out. I can say you have 4 isotopes and I can give you 3 of them. Remember, when you add up the 4% abundances, when you add these numbers up in this column, all of these together equal 100%. All right, so if I leave one of the numbers out and you're going to say I have to have that number, you have to know that I'm telling you that there are 4 naturally occurring isotopes. So when you add up the percent abundance, it's 100%. If it's adding up the fractional abundance, it's going to equal 1. All right, so you take your fraction and multiply it by your mass. And so you have to do sig figs. So you're multiplying 3 sig figs, 6 sig figs. Make sure you're doing the sig figs here. So that's going to be 3, that's going to be 3, that's going to be 3, and this is going to be 3. And then you're going to add them up. So it doesn't matter that these are all 3 sig figs. Now you're adding them up. Now it is all about the decimal places when you add them up. All right, so again, you convert your percent to fraction by dividing by 100. If you want to convert it back to percent, then you multiply by 100. All right, so again, all of these numbers have to be given to 3 sig figs over here. And so that's 2 decimals, 1 decimal, 1 decimal, no decimals. When I add these up, I give my answer to no decimals. Make sure you can do the problem plus do the significant figures correct. And once you have that number, you go to the periodic table and you find which one has a molar mass of 207, and you find that that is lead. All right, make sure you know your characteristics of a metal, a nonmetal, and a metalloid. Those are many times a multiple choice question. Okay, so an ion has a charge. If you are a cation, it's a positive charge. If you are an anion, it's a negative charge. Ionic compounds are made from ions. You had a plus ion, you had a minus ion, you brought it together to form a neutral compound. That is an ionic compound. So when you make a compound with magnesium plus 2 and N minus 3, those are ions, and you're making an ionic compound. So you have your Mg3N2 because you have to have exactly the same number of pluses as minuses. If you just had Mgn plus 2 and minus 3, that's not neutral. That would be minus 1. All compounds are neutral. And so the least common multiple for magnesium and nitrogen would be 6. Magnesium has to be plus 6, N has to be minus 6. Now you have a neutral compound. All right, you have your polyatomic ions that you have to have memorized. And so you have to know that the name of this compound. So it will say, give the formula and name it. And so you have to see again that my common factor is, again, 6 because it's a plus 2 and a minus 3. So Ca3, to get 2 of the PO4s, you have to use parentheses. And so you have a plus 6 and a minus 6. And then it will say, name this compound. So Ca, that's one of the elements you have to know. That's calcium. And then you have your list of polyatomic ions, PO4 minus 3. That is one of them, and that is phosphate. All right, so you'd have to write the formula and give the name of that compound. This is the major amount of points on Chapter 2. It is probably 50 of the 150 points is going to be naming, because there is a lot of naming. Make sure you can name these compounds. If you cannot name the compounds, you will not do well. It's not going to be any organic unless it's memorized. If you say carbonate is organic, fine. Then there's those. Cyanide has a carbon, fine. That's but we're not going into alkanes, alkenes, and alkynes and true organic chemistry. All right, so naming, remember, if you are binary, you have to know what that means. Binary, that means 2 elements. All right, so if you have a binary compound, all binary compounds end in IDE. So the name of all binary compounds end in IDE. So you have sodium bromide, which is NaBr. That's neutral. That's plus 1, that's minus 1. That's neutral. This is magnesium plus 2. So MgO, that's magnesium oxide. Plus 2, minus 2, neutral. AlCl would not be neutral because that's plus 3, that's minus 1. We need 3 of them. AlCl3 is aluminum chloride. Note that it's not aluminum trichloride. You cannot use the Greek prefixes if you have an ionic compound. Right? You know how many there are because you know the charge of the ions. All right, so again, column 1, all plus 1s, no exceptions. Column 2, all plus 2, no exceptions. Once you get past that column, there's a bunch of exceptions. So the only ones that never change are column 1 and column 2. They're always plus 1, always plus 2. All right, so remember when you're naming your transition elements, which may or may not have multiple oxidations, the ones you have memorized are the copper, it's plus 2 and plus 1. So you can simply name it copper 2 if it's plus 2, copper 1 if it's plus 1. But you also need to know the old system. And so a higher oxidation, 2 being a higher oxidation, that gets the ic ending. So that's cupric. The lower oxidation, the plus 1, gets the us ending. That is cuprous. All right. The ic does not tell you it's plus 2, and the us does not tell you it's plus 1. The ic says that it's the higher of the 2, and the us says it's the lower of the 2. For copper, those are 2 and 1. When you're doing iron, another one that you have to have memorized, the higher one is plus 3, and the lower one is plus 2. So it's the ferric ion, that's the higher, that's iron 3. The ferrous ion, that one is the lower, that's iron 2. Mercury was not put on the list of to be memorized, so you don't have to memorize the mercury. Chromium was not on the list to be memorized. You don't have to memorize the chromium. So I gave zinc on the memorized, the cadmium, the silver. Those only form one stable ion. And so you can have zinc chloride. And that is ZnCl2. You cannot have chromium chloride because chromium has multiple oxidations. You can't have iron chloride because it has two different iron chlorides. All right, so you have your list. Oh yeah, we're going to do some more of that. All right, so note that we stopped here last time and talked about a compound that would have multiple positive ions. All right, so we talked about the carbonate, and then when we put an H in front and we had NaHCO3, we had sodium bicarbonate. Which can also be called sodium hydrogen carbonate. All right. When we are looking at our phosphate here, you have one hydrogen, monohydrogen phosphate, and you have a dihydrogen phosphate. So when you put a Na2HPO4, this is a disodium hydrogen phosphate. And if you had NaH2PO4, that is a sodium dihydrogen phosphate. All right, so you have special rules when you have more than one positive ion. All right, so if you have, so the H is plus charge, and then you have your phosphate that is a -3 charge. That's why overall it's -2. And now we're going to add a metal to that. So we have not only a hydrogen that's plus, but also a metal that is plus. And for that special case, the only ones you're going to see here that would use that system is the phosphates or the phosphites. Those are the only ones that you have that are a -3. These are the only two examples where you would use the Greek prefix for an ionic compound. If the compound is made with ions, it is ionic. All right, so the only ones that would use the mono or di in naming a ionic compound are these two examples of the phosphate. None of the other ones will. All right, so again, sulfate would work the same as carbonate. So you have carbonate, you have hydrogen carbonate, or simply bicarbonate. If you had sulfate, you would have hydrogen sulfate or bisulfate. If you had sulfite, you would have hydrogen sulfite or bisulfite. The term bi is only used when you have a -2 ion. All right. So these are examples of having more than one positive ion. All right, so again, many of these questions will be on the test. You have to know that Ba is barium. That's one of your to know elements. You have to know Ba is barium. And then O, you have to know this is a binary compound. You have to know it ends in IDE, barium oxide. Cr, that is an element that you have to know. It's on the list. That's chromium. That's right off your chart to be memorized. Sulfate, chromium sulfate is the answer, except chromium is a transition element. And so you can't simply say chromium sulfate. You have to, when this is a transition element. All right, so you got your periodic table. So these are your transition elements. Transition elements have multiple oxidation numbers. Not all of them. Many of them have multiple oxidation numbers. And so you can't simply say chromium sulfate because chromium has many oxidations. So now you got to figure out what is my charge of chromium. And so you know that sulfate is -2. You also know that you have 3 of them. So I know that this is a -6. All compounds are neutral. This has to be a +6. And so I have 2 chromiums. So 2 chromiums that have to be +3 to neutralize my 3 sulfates that have a -2. And so this is a chromium 3 sulfate. Anytime you have an element here and it's not memorized, you have to, and if it is memorized as a 2 or a 3, many times you will have to put the oxidation number. Note, zinc is only +2. You don't have to put it for zinc. Silver is always +1. You don't have to put it for silver. When in doubt, put the oxidation number when it's a transition element. If you ever put a Greek numeral, Roman numeral here for a always +1 and an always +2, that will be wrong. Anytime you have sodium, you would never say sodium 1. Sodium is always 1. Magnesium, you would never say magnesium 2. Magnesium is always 2. The only time you put the number is when you have a different possibility. All right, carbonate, CO3 -2. You have to have that memorized. Potassium is in the first column. You have to know that is K. It's going to be plus. You have to know how to make a neutral compound when you have a +1 and a -2. So it's simply K2CO3. Manganese 2, again, this is a transition element. When it's a transition element, they have to give you the charge as a Roman numeral. All right, so you have, that's one of the elements that you have to know the symbol and name for, Mn. It is +2. Sulfate, memorized, SO4 -2. You just bring it together because a +2 and a -2 is neutral. MnSO4 is the formula. Again, remember, binary, 2 elements, only 2 elements, name ends in IDE. When you have 2 nonmetals, so we talked about ionic compounds made from ions. Now we're going to talk about molecular compounds that are made from nonmetals or metalloids with a nonmetal. All right, so when you have N2O4, you have to use the Greek prefixes, dinitrogen, tetraoxide. Again, it's binary, and it ends in IDE. All right, NO. When you get confused, always go back to the ones you know, which is CO and CO2. Write it out, carbon monoxide, carbon dioxide. Follow those rules when you're down here. All right, so NO would be named exactly the same as CO. Instead of carbon monoxide, it is nitrogen monoxide. The first element is the whole name of the element. The second one in a binary compound has to end in IDE. All right, so if you don't know your Greek prefixes, know them. Memorize table 2.7. You have to know the Greek prefixes for the number of atoms in the compound. All right, you common names. So H2O, if I say name H2O, there's only one correct name, and that is water. Ammonia for NH3. For your H2S, hydrogen sulfide is what I'm looking for. Again, hydrogen thinks it's a metal and it's +1 and S is -2, so you can simply say hydrogen sulfide. I will accept dihydrogen monosulfide. That would be an acceptable name. If you said I have 2 nonmetals, I'm going to name it using my Greek prefixes, dihydrogen monosulfide. Yes, that would be accepted as a correct answer. Dihydrogen sulfide, not a correct answer. Right? So dihydrogen monosulfide is how you would name it as a molecular compound. Now, if it were aqueous here, all right, if it says aqueous now, it is an acid. So anything, all compounds that start with hydrogen are acidic except for water and hydrogen peroxide. All right, so this as aqueous, so this is hydrogen sulfide gas, so it would have to be H2S gas to be called dihydrogen monosulfide or hydrogen sulfide gas. All right, so that would be the answer for gas. Over here, if it's aqueous, now we have a binary acid. And so on the test, it could have H2S gas and hydrogen sulfide, or dihydrogen monosulfide is the correct name for that. If it says aqueous, now it starts with H and it's aqueous. Now it's an acid. It only has 2 elements, and so it is a binary acid. So remember that HCl is a binary acid, and you should know the name of that. That's hydrochloric acid. All right, and so you name all binary acids the same way. They all start with hydro. All right, so binary, only binary. If it is binary, it starts with hydro. And if it's not binary, it doesn't start with hydro. So hydro, and now the name of this element, all right, so this chlorine, but it ends in ic acid, and so sulfuric acid. All right, so that is hydrosulfuric acid. That's how you name a binary acid.